Hello and welcome to the Titus Timeout podcast. I'm Jenny Abney-Civy, and today I'm going to talk about direct acting versus reverse acting. These terms go back to the days of pneumatic controls in VAV boxes. You can have a direct acting or reverse acting thermostat or controller, and then combinations of direct acting and reverse acting thermostats and controllers. So let's look at direct acting versus reverse acting. In a direct acting thermostat, when the room temperature increases, the thermostat output increases. So as a reminder, in pneumatic controls, the thermostat output is a pressure signal sent to the controller. So it looks something like this. We'll put temperature across the bottom, so as the temperature increases, the output from the thermostat also increases. Let's make a little room here. In a reverse acting thermostat, when the room temperature increases, the thermostat output decreases. And that looks something like this. Again, temperature rises across the bottom, and the thermostat output is reduced as the temperature rises. Now let's scoot this over for a minute and talk about controllers. In a direct acting reset controller, an increase in thermostat signal would cause the controller to increase CFM. So that would look like this. We'll put temperature rise across the bottom again and CFM up here. You'll have a minimum CFM, it'll modulate, and then you'll have a maximum CFM. In a reverse acting reset controller, an increase in thermostat output signal would result in the controller calling for a lower CFM. So let's draw that. We'll put temperature rise in the room across the bottom. You would have a maximum up here, the modulation, and a minimum CFM. So when you look at these two and think about VAV box, what you see is that you have a minimum CFM and a maximum CFM, and then it modulates between the two to maintain comfort in the space. Now let's pull everything back together and see what happens when you have direct acting or reverse acting thermostats with direct acting or reverse acting controllers. So let's redraw our two graphs down here with CFM versus room temperature. So in the first one we did, we had a minimum, the modulation zone, and a maximum CFM. You'll see this sequence of operations with a direct acting thermostat and a direct acting controller. This is often seen in cooling mode. So what happens here is your room temperature goes up, your direct acting thermostat output goes up, and your direct acting controller sees this increase in output as increasing CFM. So the room gets warmer, you provide more cooling. Now in heating, you would have a reverse acting thermostat, which means as your room got warmer, your thermostat output went down. A direct acting controller, when your thermostat output goes down, it reduces the CFM. So as the room temperature goes up, you get less warm air. Now let's look at the other graph. In this case, you have a maximum, it modulates, and a minimum over here. For this, you would have a direct acting thermostat and a reverse acting controller, and that would be used for heating. So the direct acting thermostat sees the room temperature go up, and it increases the thermostat signal. The reverse acting controller would see this increase in thermostat signal by reducing the CFM or reducing the amount of warm air supplied to the space. You would also see this sequence of operation using a reverse acting thermostat and a reverse acting controller. So this would be your sequence of operation for cooling. As the reverse acting thermostat saw the room temperature go up, the thermostat output signal would go down. The reverse acting controller would see the thermostat output signal go down and increase your cooling CFM. So as your room got warmer, when you're in cooling mode, you would get more air. You would use the different configurations based on your application. Much like how you want some things to fail open or fail closed, which gives you normally open and normally closed, you'll want some things to be triggered by an increase in thermostat output and others by a reduction in thermostat output. I'll go into more detail in these and the normally open, normally closed concepts all together in a future podcast that covers pneumatic controls. So that's the difference between direct acting and reverse acting. Don't forget to subscribe to our YouTube channel, and thanks for taking a time out with us.